This warning appears in IBM COBOL 6.1 Migration Guide. Migrating to COBOL version 5 or 6 is different from earlier COBOL migration in that we recommend regression testing to see if your program uses invalid data and gets different results with COBOL 5 or 6. Previous COBOL compilers generated the same code and the same data layout, so invalid data would get the same result from version to version. To summarize that, IBM is saying, you better test because invalid data now causes unpredictable results. IBM was correct from my prior shop. Invalid numeric data was one of the reasons that converting from COBOL 4.2 to 5.1 was painful and postponed. We converted from COBOL 4.2 to 6.1. There was a massive project to correct the invalid data, and B, the zone data option in 6.1 did a good job of generating executables that behaved more like 4.2 executable. Why were there so many instances of invalid zone numerics, and why did those invalid fields not cause problems sooner? In this video, I'm going to demo how spaces can become 0. And I'm going to use COBOL 6.4. This is Dinosaur Parkour, faster, better mainframe programming. Demo data area is a group item that contains a field named Zoned-Decimal. It is an unsigned Zoned-Decimal field that is 5 bytes long. Below that are two pat decimal fields. One is signed and the other is unsigned. Spaces are moved into the Zemo data area on line 19. At this point, the Zoned-Decimal field contains spaces, and the program is not going to correct that error. Line 20 passes the demo data area to a do-nothing program. Demo data area is not updated by the program, but the compiler does not know that. This call tricks the compiler so that it cannot figure out that line 19 is hardcode. Line 21 to 25 checks if the contents of the Zoned-Decimal is numeric. It is not. 5 spaces are not a valid numeric value. Line 27 to 31 checks to see if Zoned-Decimal is equal to 0. Basically, we're asking is 5 spaces defined as Zoned-Decimal equal to a numeric 0. You are hopefully thinking that test should be false. Spaces are not equal to 0. This if statement is really interesting. It can be true or false depending on a compiler option. Line 33 and 34 moves the Zoned-Decimal to an unsigned pat decimal field and displays it. Line 36 and 37 moves the Zoned-Decimal field to a pat signed field and displays it. As you can see, the code is pretty straightforward. It is time to run it. This is the output. The Zoned-Decimal field containing spaces was not numeric. That is good. The Zoned-Decimal field containing spaces was not equal to 0. That is good. Or is it? Zoned-Decimal contained invalid data. The program did not append the if Zoned-Decimal is equal to 0 statement executed. Move Zoned-Decimal containing spaces to the unsigned and signed pat decimal field do not fail. They work. The two pat decimal fields now contain 0. There you have it. Spaces just became numeric. And lucky for us, they became numeric 0s. I said a couple of minutes ago that the if equal to 0 can also be true. In this test, it is not equal to 0. This occurred because the program was compiled using op2. The compiler was told to optimize the code. This executable was fully optimized. Change the op2 to be op0. Compile and run again. Now it is equal to 0. I did another video on this situation, and I'm not going to go in details on this video. Look for my video title, Non-Optimized Code Might Act Different. As shown here, it can. I want to change the test program to prove that this is just not an issue with spaces. Line 19 currently moves spaces to the group item. I'm going to change that to move A to Z. Open tick, the letter A, the number 2, the letter Z, close tick. When this move statement executes, it is going to move those three characters followed by two spaces into the bytes labeled as zone dec. The filler bytes are filled with spaces. In other words, the compiler generates code to move the literal A to Z followed by 27 spaces into demo data area. Home the cursor, save, use make to compile the program, make it a personal edit macro, not an IBM function. Run the test again, view the output. The two decimal fields contain a value of 12,900. Pretty wild. This makes sense to me. The 1 is from the letter A, hex C1. The 2 is from the numeric 2, hex F2. The 9 is from the letter Z, hex E9. Those two zeros at the end are from the two spaces, hex 4040. Is your head doing this? My experience is that this issue is not rare. However, it rarely created a real problem for COBOL 4.2. Why? Because in most cases, the invalid values in the zone decimal field are either spaces or low values. Both of those became zeros when moved to a pat decimal field, which tend to be the desired value, which is why this problem tends to go undetected for long periods of time. Why is there not an SOC 7 when the invalid numeric data was encountered? The move zone dec to pat dec is translated into two assembler instructions, the pack instruction and the OR immediate instruction. The pack instruction packs zone dec into the pat dec field. The zone decimal field contains spaces, which are hex 40. It shows a representation of those 5 spaces in a vertical zone numeric format, 5 bytes of hex 40s. The 4s are in the zone nibble and the 0s are in the numeric nibble. That last 4 that the cursor is on top of is the sign nibble. The way that pack instruction works is as follows. Since the highlighted 4 is the sign, it is moved to the sign position of the pack number. Notice that. The sign nibble is the only zone nibble that the pack instruction cares about. The rest are ignored. The pack instruction then moves the numeric nibble into the pack decimal bytes. The zone decimal field was sized for 5 digits and the pack decimal field was sized for 7 digits. There are 2 digits remaining. Those 2 nibbles are padded to 0 by the pack instruction. The pack decimal field is currently invalid. The sign position contains a 4 rather than a valid sign. This is where line 5 comes into play. The OR immediate is going to correct the sign nibble by forcing an F into it. After those 2 instructions complete, pat dec contains a valid unsigned 0 value. If you look at line 2, pat dec is defined as an unsigned pat decimal. Why did the compiler do the OR immediate on line 5? This is something that I call sign fixing or sign correction. IBM calls it sign fix-up. The default is numproc no PFD. This tells the compiler that zone decimal and pat decimal field might not contain the preferred sign. Thus, the compiler generates extra code to ensure that the sign nibbles match how the field was defined. The sign fix-up logic is only generated for receiver fields, including temporary work fields. That is why the if zone decimal equals 0 was true when op0 was needed to compile the program. The non-optimized code moved the zone decimal to a temporary pat decimal work field, and the sign nibble was corrected in the temp field. The comparison was made using the temporary field. The fully optimized version of the code compared the zone dec field directly. Thus, no sign correction logic was introduced. Numproc no PFD is the reason that spaces can be converted to a numeric value. No PFD is the recommended setting for numproc for most shops. So you might encounter this issue. Thank you for watching.